Stop imperfect bead apex assemblies before they reach your tire building machines. Steelastic's revolutionary 360-degree inspection system automatically identifies imperfections on apexed beads. Our two-sided scan analyzes 100% of the circumference, automatically removing bead apex assemblies that fail any of 12 critical integrity tests. It integrates Inline with your existing component manufacturing equipment. Provide OEMs with traceable documentation of your bead apex components. Contact Steelastic today for a demonstration.
Hello, everyone. I'm Bruce Meyer, editor of Rubber and Plastics News, and welcome to the International Tire Exhibition and Conference organized by Rubber and Plastics News. We're certain you'll enjoy the variety of speakers and panel discussions offered throughout the conference. Our speaker for this session is Mathias Zabel, the product manager for tire and rubber products at Krauss-Maffei Extrusion. He previously worked at BASF, Elastigran, and Treuster. Mathias earned his doctorate from the German Institute of Rubber Technology. His topic today is C-Check, Inline Qualification of the Chimney in the Continuous Extrusion of Treads. Let me now turn over the discussion to Mathias.
Thanks, Bruce, for the introduction. Yeah, my presentation is about the C-Check. C-Check is a special device to detect the position of the chimney profile in a tread. Next slide. As you know, the PCR tire consists of 20 components and more. One main component is a tread, and the tread itself consists of up to 7 different rubber compounds, and one rubber compound is a chimney. The chimney is responsible for the electrical conductivity of the car. So if you have an electrical loading of the car, the energy can go through the tire into the street surface. And if you do not have any chimney, then you have some kind of trouble, because modern tires are silica filled, and silica is not has not an electrical conductivity. So it could happen if you open the door, you will get an energy shock. Next slide. There are different tread profiles on the market. Here we see typical designs. Very often we are using a pure chimney rubber compound to be sure the electrical conductivity. Other designs prefer to make the chimney out of the base, but the task is the same. The question is how you can sure that the chimney is on the right position and pierce the surface of the tread. Next slide. The company Krauss-Maffei developed around 2 years ago a device to detect the chimney position online without destroying the profile. You have a device close after the extrusion head, and a special technique can detect the chimney without touching the profile. This device is suitable for PCR and TBR treads. For sure, it is available for common extrusion speeds. As I mentioned before, it is located after the shrinkage roll or the take-off conveyor. You can detect 1 chimney up to 3 in total, and the device is available for different conveyor geometries. Next slide, please. Yeah, it's a very comfortable and gentle system. It's operator friendly, so you can detect also some kind of marks. It is not in a standard scope of supply. If you connect it, is it connected to the extrusion SPS, the system SPS? It is possible to reduce the scrap, and it is high flexible. It's automatic system. It's recipe controlled. It means if you start the extrusion line, the device is knowing where should the chimney to be, and then the measuring started automatically. And yeah, the implementation is also possible in existing lines and for sure in new extrusion lines. It's a compact design. We talk about in a height maybe 500 millimeters, in a width 250, and depending on the conveyor size, up to maybe 850 millimeters. Next slide, please. The working principle, it looks and sounds easy. We have here the thread profile. It's coming from the right, going to the left, and here an electrode, we call it a pinner. And under the thread, you have a grounded roller, and the electrode generates electrostatic charges on the thread surface. And if you have a conductive rubber compound, the energy will go into the grounded roller, and it's a chimney in the right position and pierce the thread surface. You will see an electrical signal. It means the chimney is okay or not. You will see it later in some pictures. And the pinner is moving from left to right around the chimney to see the difference between the cap, which is filled with silica, and the chimney, which is normally filled with carbon black. And depending on the conductivity, you will see a difference in the resistance value. Next slide, please. And for sure, the conductivity of the profile of the measurement system is depending on different process parameters. We have made different tests. You see at different extrusion temperatures. Here we make an, let me say, dry test. We take a sample, put it on the desk, and measured the chimney position. The profile was cold, and we make the same after the extrusion. The temperature of the surface was 150 degrees Celsius. You see a difference in the resistance, but the bell-shaped curve is on the same position. And for us, it is sufficient to have this kind of curve. We can use them to calculate a signal in order to say the operator and the SPS system, yeah, the chimney is correct or not, depending on the temperature. The chimney width in this case was 5 millimeters, the pinner distance 2 millimeter, and the speed of the pinner from right to left was around 20 minutes per meter. And you see in the middle, it's a peak. This is the position of the chimney, and left and right, you see an increasing resistance. Here, it is a sign that there is some cap component which is not able to conduct the electrical charges. In this case, it would be the cap component filled with silica. And we're using different calculation and curve fitting programs to say, okay, the chimney is okay or not. Next slide, please. Here an example, the pinner distance. As I mentioned before, we have a contactless system. Other systems using a metal wheel, which is in contact with the profile. We have no contact to the profile. It's contactless. The distance can be adjusted. we have made some tests for sure, and we adjust different distance between the pinner, the electrode, and the thread profile surface. And you see for sure the resistance is different. Yeah, because there is some air between the pinner and the surface, and it's a distance higher, you have more air. It means you have a problem with a different in the resistance, but in general, as seen before, the peak is on the same position. So in this case, it's very important if you have a distance between the pinner and the surface, and you have some problems with your extrusion process, some boards or rubber peaks or something like this one, you have to adjust a small distance that the material is not contacting the device, but it means also it's not an issue for the device itself. We are able to guarantee that the system is working, but if it's a distance too high, you see the conductivity or the resistance value between the cap component and the chimney, it will be less depending on the distance. If you have a small distance, just here, 2 millimeters, you have a clear result between the peak and the cap. If you have a higher distance, you see the difference. It's less, but it's still acceptable for us and for the tire maker to detect the chimney continuously. Next slide, please. Here we have made some tests with different speeds. It means we have a chimney, very small, 0.5 millimeters. The temperature was room temperature, because it means a dry test, and the distance of the pinner to the surface was 2 millimeters, and we moved the pinner, the electrode, across the profile with different speeds. Here we see a clear difference. It means is the speed too high in the lateral way? It is not always easy to detect the chimney if the chimney is available or is in the right position. So we have some traverse speed, and is this speed too high, the device gets some trouble. But I think in this case, if you have a lower speed and you measure the position of the chimney and the quality of the chimney from time to time, about the frequency we have to talk about, it would be enough. Normally, if you have a continuous extrusion process, we have not a jump function inside or within the profile. So if you have some trouble, you will see difference in a geometry or in a chimney position slowly. It means if the chimney is not away suddenly, it takes a little time, and I think it is enough for the device to detect the operator, or here could be some problem. The next slide, please. Here in a typical diagram of the device, you see different curves, resistance, voltage, and line speed. And the blue line it's an important one. We see some kind of traverse. The electrode or the pinner is moving around the chimney. It's going out of the chimney. You have a high resistance. It's going into the chimney. You see a low resistance. And if you give the system a limit, what is acceptable in this case was 80 ohms. You are under this limit, and it's sign the chimney is okay. After this, the system is going out of the chimney position, and you see a different. Here is some kind of cap, could be, and the resistance is increasing. And after this, it's going back to the chimney position, and the resistance, it's lower, and it means the chimney in this case is okay. Next slide, please. Yeah, here for sure you can adjust the different limits, min and max. And is the chimney not okay, you get a signal acoustically, or as a visual signal, and also you can use the signal for your storage system, your SCADA system, some kind of quality check for the tire after production. Next slide, please. What we're doing today, the system is running. It's highly welcome. A lot of tire makers using this device already. But in the future, we get the feedback from the market. It is possible to measure also the width of the chimney with your device. For the moment, we can just say the chimney is okay or not. But it seems not be good enough. Tire maker wants to know how is your size, or how is the geometry of the chimney, especially the width. So make some tests to detect the chimney and to calculate the width. You see the typical curve on the right side. We have here some kind of cap component. The electrode is going to the chimney position and out, and you see the typical bell-shaped curve. And we want to try with our tests and our development, can we calculate out of this curve the width? And for the moment, it's not possible. We have to do more tests. You see here, the chimney width would be around 10-50 millimeters, and everybody is knowing it's not a realistic value. Normally, the chimney is around maybe 2 up to 5 millimeters, and it means we have to do more to measure the width. We on a good way. Maybe in future we are able to measure the width roughly. It means we can split the typical chimney width in different parts. It means we have a small chimney, a middle chimney, and a huge chimney. And the device is able to say, okay, now we have a small chimney. Small chimney could mean that it's not acceptable. A normal chimney, a middle chimney, it's okay. And a huge chimney, I don't know what kind of width it could be, maybe 7 millimeters and more, it's not acceptable. This kind of approach seems to be possible with this chimney device, but we are not able to give a clear statement. We have to do more measurements, and we have to put more energy into calculation to get out a chimney width by using this kind of C-check. Next slide. Yeah, that is all about chimney from my side. If you have any questions, please contact me. And let me say finally, thanks for your attention. And yeah, back to Bruce.
Thank you for that informative presentation, Mathias. I would also like to thank our audience for attending this session of iTech, and thank you to our sponsors for supporting iTech Virtual 2020. If you want to revisit this session or any others from the conference, they will be available on Rubber and Plastics News website at rubbernews.com after the event is completed. If you would like to purchase papers from this and other sessions at iTech, visit itech-tireshow.com to do so. Also, don't forget that you can connect with your colleagues here through the virtual networking program, which can be found on the left-hand side of your screen. Simply click on the Meet icon to start connecting with fellow iTech attendees. And thanks again for joining us today.